Hey everyone, in this video I'm going to start by explaining simply what metabolism is. So this is 3.1 in AP Biology. So 3.1, defining metabolism. Okay, so to define metabolism in the simplest term possible, it's all the chemical reactions that take place in an organism. Right? So, metabolism is all the chemical reactions that take place in an organism. So, let's think of some examples of what this might look like. So, the first thing that could possibly be considered would be digesting food, because you're taking complex molecules like carbohydrates, which are basically a bunch of molecules stuck together, and breaking it down into energy and transforming it into glucose. So, making food into glucose, right? Another example would be actually making the energy, or would be creating new tiers. So, like creating substances for your bodies to use, like producing saliva, producing body excretions, because that is a composition of all small particles coming as being assembled together. Being assembled together, right? Okay, so let's just expand that a little bit. All right, so now let's think about why this might be important, right? Or let's go more into detail in this. So, these chemical reactions aren't as simple as just taking a molecule and breaking it down. There are a lot of steps involved in it, right? So, here is where we're going to be introduced to the concept of metabolic pathways. So, metabolic pathways are a series of chemical reactions which can either build complex molecules or break down complex molecules, right? So let's just take a simple idea of what it can possibly be, right? So say we're given a kind of, here, I think it would be easier if I just drew it. So let's say we have a molecule that is composed of a few different molecules, right? One thing you need to understand is that in the bonds that hold these molecules together, there's a lot of energy that's stored together. So in order for you to release that energy stored in the bonds, you need to break the molecule apart. So how do you break a molecule apart without any external energy? You can't do it without any external energy, right? Like you can't shatter a piece of glass without putting force to break it. So in this case, there's something known as an enzyme which can look a multitude of shapes. I'm going to draw it as a rectangle, which comes in and binds to the molecule to break it into their individual parts, right? So it's going to break it into individual molecules. So that way, when you break the bonds within each of those, whatever the bonds were holding together, you also release energy that comes out from breaking the bonds, which your body can harvest or harness to do other tasks like helping you move, right? So your body can, you can use that energy to move, or you can use that energy to think, and so on and so forth, right? So one thing that I wanted to cover before I end this video is a concept known as anabolic versus catabolic pathways. So first, what I want to do is focus on anabolic pathways. Actually, I think it would be better if we focus on catabolic because it sounds a little bit more familiar. Catabolic pathways. So if you look at this word, let's try and break it down, right? First thing you're going to see, oops, okay. So catabolic pathways are going to look, so the word catabolic should sound kind of familiar to you, right? Like you've heard of catastrophe or catastrophic, things like that, right? So it has a very negative meaning, and that's for a reason, right? Because catabolic pathways basically are pathways, metabolic pathways. Remember, metabolic just refers to something that has to do with chemical reactions. So metabolic pathways or chemical reactions that break down, let me just move this over a little bit. That break down complex molecules, right? So as you can see here, a complex molecule is something that has a lot of parts to it, right? It's made up of multiple different components. Metabolic pathways or chemical reactions that break them apart are most likely to release energy, which you can harvest and do things, right? However, and so this example up here, breaking down this complex molecule to release energy so that your body can use it to move and think and so on and so forth, is a catabolic pathway. Remember, catabolic, catastrophic, or demolishing. Another pathway, which is actually the opposite or quote unquote the inverse, is an anabolic pathway. So anabolic, ana sounds a little bit more light and kind of cheerful, if you will, right? So an anabolic pathway is associated with metabolic pathways or chemical reactions that assemble complex molecules. Okay, let's move this down. So when we talked about how saliva or other kind of substances are assembled together, say you have individual of these molecules, right? You have these individual kind of free-floating molecules that you are trying to assemble together to make a new product, right? So just think about it, right? Your body needs a lot of proteins, a lot of substances to actually function and do tasks in day-to-day life, right? So these objects don't come together unless you add energy to it. So this is like if you have a bunch of pieces of puzzles, unless you pick up and move the puzzle pieces together, they're not going to come together. So, in other words, when you add energy to this, right? When you add energy to these molecules, you are going to assemble a new complex molecule right? You can assemble a new complex molecule which can be used by your body to do tasks. So, for example, it can assemble a protein together. So, these individual molecules could be something like polypeptides, if you guys remember. That's the building blocks of proteins. If you add energy to it, you can assemble them into a polypeptide chain. And these polypeptides can be used to become, they can be used to create those ribosomes that you guys have heard of, or these proteins can be used as pretty much anything that your body needs, right? They can be used as neurotransmitters to transmit information forward from neuron to neuron, and so on and so forth. So, why is this important? Well, anabolic pathways and catabolic pathways often tend to work together. And one thing I just wanted to add before I sum the video up is that in between all of these bonds, you may wonder why we need energy to put these together, right? Well, actually, in the bonds that are formed between the molecules, there's actually energy being stored within the bonds, right? Which is what you can use again in your catabolic pathways to break it down and then reuse the energy. So, in other words, anabolic pathways will feed catabolic pathways, and catabolic pathways will feed anabolic pathways. So, that's my video on anabolic versus catabolic pathways. I hope it was helpful. And yeah, thank you for watching.